today. So the square has, as we can see here, all sides same length and all angles, Senna, thank you, 90 degrees. Where is it? Okay. So a square and its buddy rectangle have 90-degree angles in the corners. Rectangle. What's the difference between a square and a rectangle?
One is like
Leah. Yeah, so the lengths are not all the same. So the two opposite ones are the same. So we mark these the same, and these two opposite ones are the same length. Still have, what's the degrees of the angles in the corner? Still 90 degrees, yeah. Still 90 degrees. So in this one, opposite sides are equal. And all angles are still 90 degrees. Very good. Okay. The next one I'm going to look at is the first one on the list on the board. Number 3, parallelogram. And this includes this word parallel. What does the word parallel mean in geometry? Harry's got it. This. So what's that mean?
they go in the same direction.
Yeah, same direction forever and ever and ever and never meet. Yeah, so two parallel lines look something like that. They usually have this symbol. Tonight, these two might meet because I'm drawing them very quick. But they should go on and on forever and never meet. So that's what we have to draw with a parallelogram. They've got parallel sides opposite each other. So this side is parallel to this side and the same length as that side. And that side is parallel to that side. Notice the way I use different symbols for when it's differently parallel. That just denotes that this one is parallel to that one, and this one is parallel to that one. Yes?
Doesn't that mean a rectangle also parallel?
Yeah, it's a type of parallelogram, yes.
It's square too.
Yes, yeah. Okay. So for this one, parallel, opposite sides are equal and parallel. That's kind of said. What about the angles? Well, it's kind of written up there anyway, but the angles, they're not all the same anyway, that's for sure. You can clearly see this is an acute angle, this is an obtuse angle. Actually, this acute angle here is the same as this acute angle over there. And you see, if you start to flatten this down or stretch it out, these angles would always match each other because of the nature of the lengths of the sides. They're exact same. And then that this obtuse angle over here is equal to this obtuse angle over here. How do we say that? We say opposite angles are equal. Opposite angles are equal. Not all angles. Okay. And then there's a special type of parallelogram, which is, you see that a rectangle pushed out of shape is what we refer to as a parallelogram. What's a square pushed out of shape? Is this rhombus shape here. So if you're not taking notes on this, I would advise to take some notes on this and have it in your book. Angles, yes, not written, that are equal. So for rhombus, it's a square pushed out of shape. So all these sides are the same length. Try and draw it a bit better. They're all the same length. Same thing though, that the only difference with a parallelogram is that the opposite sides are not the same length. That's the difference. All sides are equal in length. The same thing, opposite angles are equal in this as well. Okay, there's 3 more we must look at. Well, 2 more that are quite important. A trapezium. There's another name for a trapezium. What's another name for a trapezium? Does anyone know? Charlotte? Yeah, trapezoid, yeah. What's the difference? Kezia?
I have a question.
Yes, sir.
For the rhombus, I can't see.
All sides equal in length.
Yeah, but it's slanted. Is the shape slanted or is it straight?
Well, shape can be put any orientation. It'll be the same shape.
Okay, thank you.
So a trapezoid and a trapezium are the same thing. It's just different countries use different words. So in Britain, they tend to use trapezium, and in America, they tend to say trapezoid. And that's the difference. It's the same thing. So let's talk about it. So number 5 on our list is a trapezium or trapezoid. You may see on exams, you're probably more likely to see trapezium, whereas on my maths, you're probably more likely to see trapezoid, but it's okay. What's special about it? Well, it has this kind of shape, kind of weird shape, and there's only one special thing really about it, is that they have one pair of parallel sides, but they're not the same length. If they were the same length, that would start to become a rectangle, wouldn't it, or a parallelogram or something. So one side, I'll use the words they have, one pair of opposite sides. Yeah.
I have a question.
Yes.
That's how we draw a rhombus like this.
You could draw it anyway, yeah. I've just tilted it slightly because it's hard for me to write. It's exactly like a square except for it's just pushed out of shape. So you can draw it with a flat base, it'd be the same. It's the same. I've just drawn it like that because it's hard for me to draw it with my right hand tilting down. Okay, so if you really want to draw it, you can draw it flat bottom as well, it's fine. Okay. There is something else in this one, that this angle and this angle, which we'll talk about at a later date, that these two angles, they add to something. What do we think they add to? This angle up here and this angle down there add to something. Harry? Exactly, 180. If you put this down here, it would complete this straight line. It's 180 degrees, yeah. So they add to 180, and this one would also add to 180. Same. Okay. And the last one that we're going to write a note about is a kite. It's like a diamond as well. Some people use diamond. But this is the mathematical term, kite. Santa's just having a chat with himself. You good? So a kite looks like a diamond, yeah. Something like that. This length and this length are the same length, but they're not parallel. You can see they're clearly crossing over. And this length are also the same. There's a long side and a short side to a kite. The key thing about a kite that we must remember is that this angle and this angle are the same, but not the top angle and the bottom angle. The two angles here are the same. So it's one pair of opposite angles are equal. And that's the pair that meet in the middle of the kite, if you want, not the top and the bottom. The top and the bottom will be different lengths. Okay. Irregular, we won't write down. It's not going to come up really. It's just any old other shape that you can draw with 4 lines that meet and has no particular property. But I'm going to concern myself with the 6 ones here. Stefanos.
Most of these shapes could be reconstructed into a square, right? Like a parallelogram. If you twisted sides,
Well, yeah, if you change shapes, you can change them into anything you want. You probably change them into circles.